We're finally ready to go, folks. Thank you. Glad you're here. Great to have an in-person meeting. The SBE, the SMPTE people, and also the Goddard Amateur Radio Club. I believe it's the first time we've done anything like this since the pandemic began. I know I've been hunkered down for a long time doing a hell of a lot of virtual meetings, and it's really good to be in person and see a lot of my friends here and make some new ones this evening. By the way, go ahead. Round of applause. If you don't know me, I'm James O'Neill. I'm a retired broadcast engineer. I did that for about 37 years. Started a second career 3 weeks after I signed off, pulled the big switch for the last time. I wound up as a journalist, working as technology editor for TV Technology magazine. Did that for almost a decade. I'm still writing for them, writing for Radio World, some other periodicals. I've done stories in QST. I am an amateur radio operator, so speak the language. Enough about me. Let's go ahead and start the business here. First of all, I want to introduce Marco Maiden here, who is president of the Goddard Amateur Radio Club. You'd come up and can conduct some business there for the club. I'll stand over here out of the way.
Okay. Okay, no microphone, that's fine. Wife says I have a loud voice, so that should work. Okay, good evening, everybody. My name is Marco Madone. I'm the president of the Goddard Amateur Radio Club.
Welcome to NASA.
Somebody has an extra microphone on.
Okay, yeah, let me turn that down.
So welcome to
welcome
NASA
to NASA
and Goddard. Goddard has a number of centers. We still have
Yeah, somebody else has a connection into the Zoom.
Okay, yeah. Okay, so there we go. So Goddard, I mean, there's a number of NASA centers. NASA, for those who don't know, is an independent civilian agency, has its own budget, its own administrator. It also has its own television channel, which is kind of unusual, NASA TV. It's been up for a number of years. I'm not sure how long, but it's a while. It has distribution on satellite and also does streaming like everyone else these days. For a short time, Goddard was actually co-located with WWV in this building, the Goddard Amateur Radio Club, I mean, and Goddard itself. And so the centers, NASA centers, have their own specialties. Goddard is actually communications and earth science. And so one of the things Goddard did for years is run what was known as the ground network during the Apollo era and after, and also the tracking data relay satellite. So Goddard, like I said, did a lot of the communications for Apollo. Back then, there was no the TDRS, the space network, was the satellite that supported the low Earth orbiting missions, but that didn't come until the 80s. So it was just the ground network of stations around the world. NASA's about 60 years old. The club is about 50 years old. And it employs about Goddard itself employs about 10,000 people. Also, just one other thing of note, Goddard did actually assemble and build the current James Webb telescope that's up in space and working quite well. So the Goddard Radio Club started actually pretty much when the center started in this building, and actually benefited from some of the WWV facilities. Originally, the antennas for the club were actually part of the old WWV antenna poles. Also, I should mention that even though the Goddard Club is primarily Goddard employees and people associated with any licensed amateur can be a member. We do have a local repeater, which is open to all. It is now recently, a few years ago, relocated to 1 mile north of the campus and we've had excellent support from the center. We got new antenna poles and so on. The club has built some various amateur satellites. Probably the most interesting that maybe some of people here have heard of is the AMSAT Oscar 7. It was built in 1974, did its service life. I think it was supposed to last, 5 or 10 years, and then it died. Battery shorted out, and 20 years later, thing came back to life. The battery's unshorted, and now whenever it's in the sun, it works to this day. So I guess that says something about the quality of the build. One other thing that we did shuttle retransmission, and this is how I actually found out about Goddard myself. When I was in high school in New Mexico, I heard all this shuttle communication on HF. And I was like, wow, where's that? Goddard, Greenbelt, Maryland. So Goddard actually set up a broadcast studio, and I should say we don't broadcast, we retransmit. Broadcasting isn't allowed on the ham radio band, so we retransmit, and we got special permission from the FCC to do that. The shuttle communication did that for years, kind of made us famous. People all over the world listen to that. Anyway, I guess I need to keep this short for the main event. So I'd like to thank everyone for coming, and thank the support that we've got from the center. And thanks, everybody.
Thank you, Michael. Thanks, thing. And we need to do a little bit of a business meeting here. SBE Chapter 37. Do we have somebody here? Do we need to conduct some business for Chapter 37? Okay.
I will make a try if it doesn't cause audio problems. Eric Hain, I'm the chair of Chapter 37. And I think the biggest part I have is that we will be having a certification exam on Saturday. That is the first one that we've had in quite a while. So the good news is hopefully people are back in the swing of getting certified. Take a look at our webpage for future certifications. We're also working with SMPTE right now to put together a holiday party, which I think is mid-December over in Shirlington at the Busboys and Poets that's near WETA. So if you can get to the SBE page or the SMPTE page, you should be able to sign up for that. There is a cost to cover dinner on a per person basis, or if you're a company that wants to sponsor, there's an opportunity to set up for that. We have several interesting programs getting ready in 2023. I probably can't think of all of them right now, but we're going to be discussing the combined antenna that was put up at the WAMU site. We're also talking with Leader Instruments to do a presentation. I'm not sure if Fred can jump in on that, and I'm not sure if it's wise. Just keep an eye on the SBE37 webpage and the upcoming events, and that will be helpful. I'm kind of running out of screen windows here, but let me see if I have the upcoming events.
December 14th on the holiday party over at WETA. Can you hear me?
Yeah, we've got tonight. The holiday party is the 14th, and there is a link on the front page of the SBE chapter meeting or the SBE37.org, and it's probably best to not get too far ahead of ourselves into the future, but we're still trying to be a very active chapter, and we have several meetings that are going to be coming up. We've got probably 4 or 5 of the first months of 2023 mostly figured out. So I'm going to go back on mute because I think I'm responsible for part of the audio difficulties. And I actually also have another thing to attend. So Kent is a co-host of this meeting. He is going to stay here and we'll close out the meeting when we're all done. And I thank everyone for coming.
Okay, thank you, Eric, and from wherever you are, and safe travels getting back to the DC area. Anybody here from SMPTE want to conduct a little business, tell us about some activities going on with the SMPTE section? No hands? Okay, well, I understand we have some people here, some members from Baltimore SBE Chapter 46 and the Chapter 60 in Richmond. Show of hands, would you stand up just and introduce yourselves? Or is this all virtual? Okay, well, wherever you are down there, thanks for attending the meeting. Glad to have you. I do want to recognize AIM tonight for providing the food. Very generous of you. And also Jeff Elliott from AIM. Where are you? I didn't get a chance to meet you before. Come on up.
Here in 1965, and it was a different place. It was completely surrounded by trees, and there was one place to eat, and it was all the way over where the Beltway was. It was called the, I don't know, it was some bar. And when we went out to eat, we usually didn't come back. So we've been here a long time. And I'm an old Bendix field engineering guy, who then went to work for Allied Signal. And after I went to work for Allied Signal was bought out by Honeywell. And finally, I decided to retire. And the three of us bought up everybody that retired and have worked for our company and sold them back to the government. Because they knew stuff that other people didn't know. And I think some of you guys can relate to that. So we've been in business since 2004, and we subcontract with KDR. We just finished a launch of Wallops, all the TV work that you see there. The TV here, the Goddard TV. We have people there that work for KDR and work for us. And also we do satellite engineering. The satellite engineering is over in Building 32, space satellite, looking at the Earth, et cetera. And we get the legacy satellite stuff. And guess why? I think it's because they don't want their name in the Washington Post if we send the wrong code. I'm just saying. Maybe, I'm not sure. But it's great working for KDR. It's great working at NASA. NASA is a place, the folks who don't work here, is a very close-knit organization. You don't know who's NASA and who's the contractor. Everybody works together and they work toward a mission and they get that mission done. And take a look at that. That's why Ukraine is winning and the Russians are losing. You have to work together and you have to have sergeants. And we really, there's a whole culture here, great place to work. And yeah, I kicked in for the food. My other two partners didn't want to pay, but I talked them into it. So.
Okay, thank you, Jeff. Thanks again for providing the food. Big round of applause. Okay, don't want to believe DJ here. Yes, I'm supposed to. I didn't meet the DJ. Are you in attendance? Where is DJ? No. Well. Okay.
We want to say thanks to the visitor center for letting us use the facility.
Yeah, thank you. Thank you.
and the exhibits are going to be open, so until
okay.
now, anyway.
Okay. And if you're wondering why I'm here tonight, you can blame this man over here with the maroon shirt. He said, do you know, we're going to do a program on WWV. Do you know somebody at NIST who might be able to speak on the subject? Well, I know some NIST retirees here in the area. None of them were with WWV, but we did some networking. And lo and behold, we have, excuse me, John Lowe here, who very graciously agreed to travel across several time zones. Triple whammy there with the shift from daylight savings to standard time too. So really appreciate his coming. I'm going to introduce John properly in just a minute. But again, Fred asked me to say a few words here, tell maybe an anecdote or two involving WWV, involving this sort of thing. And just in order to set the stage for this, I mean, my goodness, look where we've come in the last century and a half. Thinking about this, before a lot happened here in this country, we didn't pay too much attention to time. You got up with the sun, you did your work, whatever it was, you went to bed with the sun. No time zones. Every little town, if they wanted to mark time, it was when the sun was at its highest position. That was 12 noon. Prosperous enough town, there might be a church steeple with a clock in it. You could set that to local time. Might be some sort of a municipal building with a clock tower. That's the way people got their time. It didn't really matter until the railroads came along. And all of a sudden, you've got railroads, you've got schedules. And as it worked out, of course, every town, every city is a little different depending on where they are, latitude and longitude. When that big ball of fire is exactly as high as it's going to go for the day, that's 12 noon. Well, the railroads tried to assist their passengers. They printed these offsets. You're in St. Louis, it's such and such a time. You're in Chicago, it's a little different time. Think about it, though, how clunky this was. Something like 300 cities, each one having a different time. Just between D.C. and New York. Say, I went from D.C. to New York. If I forgot to set my watch ahead 12 minutes, I'm going to be late for appointments. And when I come back to D.C., I have to remember to set it back 12 minutes. That was the way of the world until about 1873. The railroad said, enough of this foolishness. Let's get together and establish some time zones. The U.S. railroads, the Canadian railroads, and it didn't really catch on. It's a new idea. No, we can't consider that. It's not invented here. No. Finally, would you believe it? 1918. That's when the Calder Act was passed. That officially, act of the U.S. government, Congress, that officially set up these standard time zones we know and love so well. And also, by the way, you can blame them too. The Calder Act also established daylight saving time. Okay, something else kind of happened when we got into the new century. This thing Marconi and some others have been picking away at, radio. A lot of people not a lot of people at first though, again, it's a new idea, not invented here, see some value in this thing called radio, particularly the U.S. Navy, because you've got these ships out there, they've got chronometers on them. They need to set these, look, sight a star, sight the sun or something. If you know what time it is, you know the elevation of these celestial bodies, you can get a fixed latitude and longitude where the ship is. But if this chronometer in the ship is not keeping accurate time, you could be off a heck of a lot before you realized it. So the Navy seized on this. They set up a very powerful radio station in Arlington. It's over about where you see this memorial there to 9/11, not far from the Pentagon. They called it the Three Sisters of Arlington, three big towers, ponderous towers. There are pictures that exist. And there's a very high-powered transmitter. First of all, they transmitted time and code. Then later, when somebody learned how to modulate things a radio carrier fairly efficiently, they started doing this with speech. And of course, this got the attention not only of the Navy, but a lot of people across the country, particularly jewelry stores, because Western Union, of course, was in business long before NAA, but it cost money to go to Western Union and get a time check from them. But here it was free. All you needed was a receiver. You could pull down NAA and you had a time signal. Well, this is sort of leading into what John is going to talk about. But I've got one little funny story, and then I'm going to get out of here. I know you're not here to see me and hear me. You're here to see this fellow from NIST who traveled all the way from Boulder. But I have to tell the story. If you could put up the first slide. Anybody know who this person is? Show of hands. No? Okay, next slide. Maybe this helps. You're drawing a blank? Okay. Gentleman is Paul Wilbur Klipsch. Okay, go back to the other one. I want to talk just a second. This is his seminal invention. There's a cutaway there, the Klipsch horn. I could do a whole program about Paul, but again, brevity. This is a high fidelity loudspeaker. He actually got the patent on the base end. It's a folded horn speaker, extremely efficient speaker. I guarantee you, average listening room, you cannot stand to be in there with more than 3 or 4 watts in the speaker, the way it converts electrical energy into sonic pressure. One of Paul's expressions, what this country needs is a good 5-watt amplifier. Okay, I was fortunate enough to grow up in Hope, Arkansas, where Paul had been stationed during World War II. They brought him to Hope to do time of flight measurements on projectiles. There was a proving ground there where they tested munitions for the Army. We're going into World War II. So he patented the speaker, the bass end, before the war, finished it after the war. But the man, I'm trying to come up with a good word. Well, let me back in my relation with him. About the time I was 13, I was introduced to Paul. He and his wife never had children. He had several kids. He hang around his lab, hang around his shop, fly with him on business trips in his airplane. Today we would call it mentoring. That was a highfalutin word. We didn't use that word back then. I just was one of the kids that got to hang out because I was interested in the sciences, particularly electricity and electronics. Learned more math from this man than I learned from any of my high school teachers, but I'm digressing. One of the things I noticed particularly about Paul was his penchant for accuracy in everything he did. He got a new airplane, he did plots and graphs, just like his speakers when he come up with a new speaker, evaluating the speaker. Plots and graphs, everything had to be recorded, umpteen measurements. Put up the next slide. Okay, yeah, this was what his claim to fame was, but he had something like 40 patents. His first patent was on improving the accuracy of small bore firearms. But a certified genius. Okay, next slide, please. And you can still buy a Clipshorn today, a speaker that was, as Paul said, I scummed the scheme for it before the war. You can still buy the speaker if your credit card will go that high. You can order them on Amazon. I took that off Amazon. Okay, next slide, please. I'll make this very quick. Yeah, here's Paul at an airport. You might notice something interesting about his right arm there. He holds up his copy of the Wall Street Journal. Next slide, please. Close up there. What do you see? Not one, not two, not 3 watches. He wore 3 watches just like this. And he also carried in his pocket Hamilton Railroad watch. He would average. I'm not kidding. Well, this is where it gets funny. Next slide, please. 1961, Bulova comes out with this remarkable new watch. It doesn't use the same type of mechanism, spring wound mechanism, to drive the hands. It uses a tiny little tuning fork. You can see the coils up there at the top of the copper wire. Very revolutionary watch. A lot of claims made for it. If you read down at the bottom, 99.997% accurate. Okay? That's about 2 seconds a day, or maybe a minute a month. Well, probably not a good thing to sell a watch to somebody who is I guess maybe the right word, obsessive compulsive, anal retentive. We didn't use those terms though back then. Just somebody who's obsessed with accuracy. And of course, as soon as he gets the watch, he starts keeping tapes. Okay, it doesn't do a minute a month. Actually, this is a letter from Paul to the Bulova watch people in Flushing, New York, dated 9 August 1961. And this is an excerpt there. You can read that a little better. He's checking his watch against WWV quite often, and he talks about one jump there when it slewed 25 seconds one day. He's not happy. He wants some satisfaction from Bulova. Okay, he gets a sort of a delayed response from Bulova. He wrote that letter the 9th. He gets a response. They apologize for taking so long to respond to him. But next slide. Okay, this is how they close a letter. He's checking his watch with WWV. There's really nothing wrong with our Accutron, but they're saying the time signals from this radio station can be off by 20, 30 seconds or even more, depending on how long it takes the announcer to to get the mic open, look at the clock, and no. So here's somebody at Bulova who does not know what WWV is. They think it's some small town southern radio station. So that said, it gives me great pleasure to introduce the former manager of this small town southern radio station with these very inaccurate time signals. As I said, came all the way from Boulder. And again, John, you want to tell us a little bit about yourself? Oh, let me do that. I probably should do that to make it proper here. Yeah, you retired after 34 years with NIST. You were in charge of WWV, WWVB, WWVH. I'll let you explain all the alphabet soup there. You graduated University of Missouri, also at Kansas City, also University of Colorado. You got the Department of Commerce's gold medal for your efforts in connection with constructing a national frequency reference. So, man, has seen it all, done it all around WWV. So it gives me great pleasure to do something, I guess, maybe subconsciously. A lot of us have been wanting to do this ever since 1962 when Jack Parr left The Tonight Show. And now, here's Johnny.
Thank you. Thank you, James. I've actually not been introduced that way. Someone's phone.
Oh, that's feeding the Zoom call.
Oh, I leave it here then. Okay, very good. Well, let me get my spectacles on. So thank you very much. Yes, thank you, James, and thank you for the Society of Broadcast Engineers, Motion Picture and Television Engineers, to the Goddard Spaceflight Amateur Radio Club, and I'd also like to thank Fred Willard for being the man behind the curtain. And so today I'm going to go ahead and talk. I'll give you. Is this going to be a good one like that? So today I want to talk to you about the early history of radio. Then I'm going to talk to you about the history of WWV, and I'm going to concentrate mainly on that. And I'll also throw some information in. Okay, that's not going to work. Hello? I did it. Okay. And then I'll also throw some information about WWVH, WWVB, WWVL, other radio stations that we've run. So let's begin all the way back to the U.S. Constitution, where in Article 1, Section 8 states Congress shall have the power to fix the standards of weights and measures. Is that several agencies have taken that task on over the years, but the main device, and that includes just weights for a troy weight, avoirdupois, capacity, bushels for crops, gallons for wine, temperature and distance, and time. And as was mentioned earlier, time was mostly of the time, all about just the time of day. Okay. That's going to bother me. So, but time, as we all know, is frequency. So if we would, then in March 3rd, 1901, the National Bureau of Standards consolidated all of these different measurements groups and capacity groups into one entity, and it was led by Mr. Samuel Wesley Stratton, who was appointed by President William McKinley. Dr. Stratton was director until 1923, when he became president of the Massachusetts Institute of Technology. He oversaw and directed, and most importantly, he hired the right people during much of the early development of radio, including the origination of WWV. Historical note, President McKinley was assassinated just 6 months after the beginning of at the beginning of NBS. And just 3 months after the assassination, Marconi successfully transmitted the letter S across the Atlantic Ocean using wireless technology. Wireless, a term used for a while at that point until audio sound was modulated onto the carrier frequency. And I find it interesting that the term wireless is now used again, and it's making a comeback. By the way, the Marconi Company held nearly a monopoly all during this period on radio technology right up until the beginning of World War I. Meanwhile, the National Bureau of Standards, was moving way out on northwest of Washington, D.C. on Connecticut Avenue and Pierce Mill Road in Chevy Chase. That was way out. Here's an artist's conception of that facility and an actual aerial view of the complex. This site has now been all torn down and is now a small park just south of Van Ness Street along International Drive. One of the first things that Director Stratton did was he hired Louis Austin. Mr. Austin was a Vermont native who was educated at the University of Wisconsin and in Germany in Strasbourg, and he wasted no time from his hire to publish his very first article, a detector for very small alternating currents and electrical waves. Very much sounds like a receiving antenna. Interesting fact, Dr. Austin was never paid a salary by NBS. Dr. Stratton had arranged or allowed for someone else to pay. I guess in the long tradition of other agency funding, as we're all aware of other agency funding, I believe that continues to this day. The other agency that was mostly paying for Dr. Austin's work was the United States Naval Wireless and Telegraph Laboratory, later named the Naval Research Laboratory, now located in Bellevue and Anacostia. Director Stratton also hired Howard Dellinger, later known for the Dellinger effect, which was how solar flares cause shortwave transmission fading. We'll talk about that in just a second. He was actually started at NBS in 1907 as an intern from George Washington University. He did not get his PhD until 1913 from Princeton. So this is another tradition of NBS, and I think a lot of agencies, probably very much like NASA, investing in and supporting students. Then in 1911, Frederick Colster was hired, later known for his decrometer or decrometer. You have to be careful how you pronounce that. More on that in a minute. He was a Swiss-born electrical engineer who had been working with Lee DeForest on electron tube technology. So the stage was set with strong scientific staff, many of whom I haven't mentioned at this point, and an entire crew of support staff. So one of the first major events was the Wireless Ship Act of 1910, requiring passenger ships to have radio equipment with a range of 100 miles for ship-to-ship and a ship-to-shore communication. This legislation was prompted by a shipping accident in 1909, where a single wireless operator saved the lives of 1,200 people. So this act was set. The range of 100 miles happened to be just what the Marconi transmitters could reach, surprisingly. So here is actually a recreated ship radio room from about 1910, showing the setup for about 1910. Basically, all the equipment from the Marconi company was used in these setups. In fact, the way they tried to keep their monopoly, Marconi equipment was prohibited from relaying any received signal from anything other than other Marconi equipment. They tried very hard to keep their monopoly. Next major event occurred on the evening of April 14th, 1912, when the Titanic struck an iceberg. There were 4 ships within 60 miles when the iceberg was struck, and they first sent out their SOS signal. Then the ship lost its power soon after striking the iceberg. The Marconi spark gap transmitters were so broad-banded that it was difficult for any 2 transmitters to operate in the vicinity of each other. It's actually a ship called the Californian. It was 10 miles away from the Titanic when it struck the iceberg. But the Titanic had asked them to turn their transmitter off because they were interfering with them sending messages private messages back and forth to shore. It took another 2.5 hours for a ship, the Carpathian, to actually show up and start saving people. Even though the Carpathian had saved quite a few people, if the Californian had been online and listening to their SOS, many, many hundreds more would have been saved. So that led almost immediately, this was in April, remind you, almost immediately the 1912 U.S. Radio Act. Now, in that 2-year period, they had gone from the wireless terminology to the radio terminology. The Radio Ship Act, and the Radio Ship Act had several important advancements in this radio world. First, backup power was required in all radio rooms. They no longer could just run off of the main power from the ship. A priority frequency band was set up for all distress signals. Interesting one for all of you folks. Licensing for amateur radio broadcasts were now required. And that was also the period of, I was going to say, Dr. Colster actually attended the International Radio Telegraph conference and came back, and he was the one that pushed the U.S. Radio Ship Act through Congress. So after the Ship Act was passed, Dr. Colster immediately went into work with his team, and he developed the decrometer, or the decrometer, basically a frequency banded power meter with directional capability through the orientation of the receiving antenna. Spark gap generators soon after this were required to be damped. Had to damp the spark gap to not only narrow their band, but also reduce the amount of power that they were transmitting. Mostly through, and then there was another great emphasis to start doing this with electron tube equipment. As we said earlier, Dr. Colster worked with Lee DeForest on this. Next one, and here is actually a portable version that was designed and developed soon after that by the radio section. And you can see here the directional capability was by this loop antenna. These were actually then used on all ships at sea. But it led to almost immediately the idea of fog signaling. Pretty much the first concept of navigation at sea, no longer having to use the stars, as James was talking about earlier. You could actually listen to different broadcasts of transmission, of radio transmission from each lighthouse. The Bureau of Lighthouses, that's the BOL, Bureau of Lighthouses had required that all the main lighthouses in the United States install radio compass transmitters in their lighthouse. Here's a couple pictures of that. Here's the experimental setup that Dr. Colster put together. Here's actually a lighthouse spark generator from that period. And then here was the shipboard actual detector. And you can see here the loop antenna on a gimbal, allowing it to tell the directions of that very space. Well, meanwhile, in 1913, the radio section had moved into their own building called the East Building there on Connecticut Avenue. They shared their space with the Navy's radio group and the Army's Signal Corps radio division. As was mentioned earlier by James, the radio group of NBS worked very, very closely with the military groups from both the Navy and the Army. This was the building. You can see one of the masts right up behind here. I think I have some more pictures of this. But this was their own building that they moved into in 1913. Well, that very next winter, they had a massive snowstorm at the time. And this did lead to some good. They decided that new antenna fields had to have improvements both structurally as well as in their design so that they could withstand severe weather. Here's a picture of the Navy's radio section transmitter room. Maybe tough to see, but on the table here is a standard inductor and a standard capacitor. And then also here is a two-coil directional antenna. The antenna in a two-directional device that actually improved the ability of being able to determine which direction signals were coming from. And then on April 6, 1917, the U.S. declared war on Germany, and immediately all citizens and commercial operations of radio broadcasts were greatly restricted or not outright forbidden. This was the end of Marconi's monopoly, and money and resources and people were poured into the combined military and NBS radio groups. An entire lecture could be given on the radio advances that were made during the Great War, concentrated on portable radios, airplane radios, navigation by radio, electron tube development, crystal rectifiers and oscillators, and many, many others. Oh, that should have been right where we were that. That was all the things that happened in the war years. And here's just a few advances. For instance, a ship-to-shore and ship-to-ship radio communications, and navigational encryption and enemy interception of signals were all greatly improved. Here's a picture of a sub at dock in New London, Connecticut. You can see its antenna. Come on now. You can see its antenna strung up and across, and it used the actual base of the submarine as the return. This antenna would actually work partially submerged. So there was communications. They did not have to come completely out of water. There was such powerful transmitters and stuff that we used. This could actually function partially submerged. Another great advancement during the war was the creation of 2 epic publications by the radio group, as well as their military compatriots. The principles underlying radio communications and radio instruments and measurements. These became foundational sources of information, but they were not widely distributed during the war. These were all held within, of course, the groups that did it. But after the war, these became foundational works for most people to understand and figure out how to operate radios. Their major advancement was in electron tube technology, just like they had promised of the Lee DeForest type, they called it. Over 40 classified and unpublished papers were on this very subject alone. One result of this work, spark gap generators were obsolete. Nobody made any spark gap generators anymore. Another great progress was made in shielding techniques, shielding in cables, shielding in equipment, shielding for measurements. Here's a picture of an NBS Faraday cage used to shield from the powerful NAA broadcast just across the Potomac in Arlington. Quick side note, the Arlington broadcast. When we were trying to make another WWV LF radio station, I actually went to Arlington and we came very close to taking over those towers to build our own radio station on that at 40 kilohertz. Into that side note. Okay, next to you. Another great advancement, and I'm especially proud of this one, of course, is that NBS pioneered employing very deserving women in positions of science, not only through the war, but they continue to do that even up to this very day. My very own boss, favorite boss, Catherine Gebbe, who's unfortunately passed now, was an example of that. In 1918, Dr. Louise McDowell became right at the end of the war, became the professor of physics at Wellesley College. So, next one. The war ended November of 1918. NBS was recognized for their contributions, and especially the radio section, for all the things that they did. They were given expanded responsibility across industry and engineering, amateur science outreach, U.S. government support, foreign relations, education programs and involvement with also scientific societies. In the spring of 1919, the radio section demonstrated a full audio broadcast of a popular song at that time. It was only a few hundred yards down from the auditorium, down to an auditorium at Johns Hopkins University. But electron tube technology demonstrated full fidelity transmission. So then on October 1st, 1919, a bulletin announced the assignment of the call letters WWV. The date we celebrate as the origination of the radio station. I had a brief discussion on the phone with James O'Neill about this being WWV on-air anniversary, and we'll get to that in just a moment. But this is the date that we celebrate. Next. So 1 year prior to the end of the war, 1 year prior to this, 1 month before the end of the war, the radio section moved into its new building, the radio building, common name, kind of the last available piece of land on Connecticut Avenue. You can see the tower that is part of the antenna system. Yep, that is part of the antenna system. Go ahead. Is it frozen? So this is the new building There we go. So that was part of the antenna system. You can see the new building here. That was the antenna you could see. And this is part of the new antenna system running along the road, the incoming road onto the new radio buildings. This is the flat top T antenna right here, which is has a natural frequency of 750 kilohertz. And it did all of the broadcasting below 300 kilohertz. And then this T cage antenna out over here with the counterpose 10 foot above the ground. It had a natural frequency of 1350 kilohertz, and it did all of the broadcasting above 300 kilohertz. Here is a transmitting and receiving room on the second floor of that building. You note the large loop antenna. Large loop antenna. There we go. The large loop antenna running right here. That was actually used for receiving signals from Europe. So WWV was operating periodically from here, but not as a standard frequency broadcast, as we all know it. What they did was propagation test, reception test, tuning test, and they pioneered, in my mind, the very future of radio, such as music broadcast. Following up on the Johns Hopkins experiment, they started broadcasting music using a Victrola phonograph, and through a morning glory horn, you can see the morning glory horn here, into a telephone and microphone pickup, straight into the microphone, and then they would broadcast this on multiple frequencies during the course of days using U.S. Army Signal Corps transmitters. Later that very same year, they developed their own 50-watt electron tube design using a Columbia phonograph, feeding straight into the modulation and oscillation circuit. No horn was allowed, no horn was required, which got rid of all the ambient noise, made much higher fidelity of their broadcast. Phone is used for voice announcements only, and this design was made publicly available and used by many, many startup broadcast stations across the country. Another extremely popular and valuable service pioneered through WWV was market reports, requested by the Bureau of Markets, Department of Agriculture. Prior to this, it would take days, maybe even a week, for farmers and buyers and sellers of commodities to reach this information. Many of the rural radio stations all across the United States were created pretty much just for this service, to broadcast market reports. Here's a picture of two early market report receivers. The next thing, 1920, NBS started a long relationship with the American Radio Relay League. The ARRL was started in 1914, but restricted, very much restricted during the war, but expanded thereafter. Here is an announcement of a fading test using WWV. During this period, 1920 to 23, WWV pioneered many other aspects of radio, such as the Adventure Series, a comedy show, and yes, the commercial. They actually had commercials for soap. So, another thing that the NBS did, the radio section did, which is extremely important, was they made radio accessible by developing radio receiver designs and instructions through the NBS circulars. 5 cents for a circular, later on 10 cents, for plans to build your own crystal radio set with parts lists from anywhere from $6.50 to $75. Millions of these were built. Next, including what I call the first boom box. A portable radio receiver complete with batteries. All these radio sections activities helped launch the beginning of the golden age of radio. In 1921, it was estimated that there were less than 7,000 private radio sets in the United States with just a few broadcast services. And by 1928, there were over 10 million radio sets and hundreds of services. So in a short span of 7 years, the radio world exploded. Also in 1922, the radio section developed a remote relay. Now, remote relays had been done before, such as by Tesla, but now using electron tube technology, by being powered by either AC or batteries, and soon miniaturized, and most importantly, because of modulation, able to have multiple actuators within the relay. We all know what remote relays can do, pretty much powers and actuates landers on other planets today. Should be familiar with, of course. So during this burgeoning period, more and more broadcasts were filling the spectrum, the airwaves, and interference became the main problem, mostly from radio stations straying from their supposed standard, from their supposed frequency, allotted frequency, assigned frequency. What was needed was an easily obtained standard frequency calibration service. So in March of 1923, WWV becomes standard radio reference broadcasting service at 200 megahertz, kilohertz, 300 kilohertz, and 545 kilohertz. This is the service that WWV is known for today. And so is this the anniversary that we should celebrate? I say that the 100th anniversary would be next year, next March. I think we should maybe celebrate that one because it gives us another opportunity for a 100th anniversary party. So, next one. So by 1924, the radio section had reduced to just 14 permanent staff from over 40 at the end of the war. One, due to low government wages, heard of that here, and due to mostly the opportunities that were available to people in the burgeoning radio industry. So they had lost lots of people, but the main core still remained. And this dedicated group of people continued to pioneer. So what's next is a few more accomplishments, some explanations of what happens with WWV as we move on. And one of the more interesting ones, in 1926, just northeast of the radio building on Connecticut Avenue, at the Compass House, as they called it, they constructed an airfield runway localizer for pilot visualization of course deviation. 2-coil antenna system, both run off of the same frequency, but one modulated at 500 hertz and the other modulated at 1,000 hertz. Later, using this very same concept, they built an operating system at College Park Airfield, College Park, Maryland, using a single wire triangle antenna and 2 vertical planes. These replaced the coil antennas. They had a rotating distributor at the base, which allowed equal power broadcast down a runway and ability to swing to other runways that happen to be on the field. Here is the basic cockpit instrumentation that they developed. It's simple to see. If you're outside this modulated signal, you'll get an indicator. If you're on the other side, you'll get an indicator. If you're running down the correct runway, you'll get the correct indication. Not too different than what we use today. Here's a picture of the College Park Airfield in 1927 using that very equipment, that very same instrumentation installed. Another incredibly important thing, I believe, that was done at this time was they discovered the distinct layering in what was then called the Kinley Heaviside ionized atmosphere. They did this using a vertical antenna and a loop antenna to observe and measure time of arrival and angle of incidence of differentiating ground wave and sky wave signals. They did this at 770 kilohertz initially, but then at multiple frequencies. This started to explain the observed fading that people were observing on this frequency band. Next one. Another thing that they figured out was that this diurnal day to night transitions, of course, happened, but there was association to the sun and its observed sunspot activity. The sun goes on an 11-year cycle. This is when they were first starting to figure that out. There's an 11-year cycle. This runs from 1924 to 1929. They kept very distinct notes on all of that. Next one. Another thing that they did during this period is they started developing higher frequency antennas, broadcast antennas. Here's example of a 30 megahertz, a 10 meter antenna, broadcast antenna. These higher frequencies were limited by the inner electrode capacitance of the transmitting tubes. So they started designing antennas that changed the inductive drive of these things. This one, for instance, is a single turn loop that fed two cage antennas serving as a dipole reflector of a cylindrical shape. Reflecting this reflector was a 40 vertical lines that were dropped down. Here's another antenna they designed, a 100 megahertz antenna using multiple loops, which combine properties of condenser as well as coil antennas. Loop antenna on top of the roof there, that's not part of it. That large loop antenna. Go ahead. So the Connecticut grounds had pretty much run out of room. So they started using field stations around the area, such as this one here at Brooksville Road near Shepherd Street in Chevy Chase. It's very far from here. In 1932, NBS required 200 acres at Meadows, Maryland, 14 miles southeast of the Bureau. They operated here until 1943. You can see the pole structures here of the antenna field as they ran across. They ran that until about 1943. In May of 43, Camp Springs Army Airfield took over here. This was the training base for P-47 Thunderbolts, and then renamed Andrews Air Army Base in honor of Lieutenant Colonel Frank, and then named the Andrews Air Force Base. The antenna field, as far as I can tell, is really difficult. The antenna field strung right across these main runways where they replaced it all. Another field site was at Kensington, Maryland, 5 miles north of the original Bureau. They occupied this in the mid-1920s until early 30s. They did many of their ionospheric measurements here until this facility was moved to Beltsville, Maryland in 1932, where they continued doing the ionospheric research, but this time doing multi-frequency sweeps. Here's a sample of that results. You'll note the sweeps are from 2.5 megacycles to 4.4 megacycles. And I think the really incredible stuff here really obviously shows you the E field and the F field distinguish as they ran these across. Next one. In January 1931, WWV moved to the College Park, Maryland site. This is the transmitter house for WWV at that time. And in this little building, they jammed all of this. There was three each. There was three 200 kilohertz crystal oscillators in this temperature control cabinet. And then, of course, a 5 megahertz transmitter, multi-frequency transmitter, and a switchboard to run all of this out. This 5 megahertz, 1 kilowatt transmitter, remember that, it was used again. Then, in December of 1932, WWV moved again to another portion of the Beltsville site. I showed you the Beltsville earlier. This was another part of that whole land area, and this is the Beltsville site. They took over an old house, an old farmhouse, and they renovated this farmhouse and put the entire new WWV broadcast facility there. Next one over, you can see it. I've outlined where the antenna fields are at this site. Go ahead. At this site, probably the most important thing is they took the 5 megahertz broadcast and took it up from 1 kilowatt to 30 kilowatts. The massive new 30 kilowatt transmitter chain for WWV. The rectifier, the exciter, and the big amplifier. I'm sorry?
Is that a shielded room?
Yes. They started doing shielded rooms at this point. This didn't last long here, though. Well, no, this lasted for a while. I'm sorry, it was the one earlier. This was a shielded room. They also, at this point, started doing a time code generator. So on the second pulses, they weren't doing what we understand now as the 1 kilohertz tone. They were actually doing 5 cycles of 100 cycle tone, which is difficult to hear, but it was the beginning of second pulses. So now WWV started to get familiar to what anybody that has used WWV in the past. They've got a 5 megahertz, 30 kilowatt transmitter. In 1935, they added the 10 megahertz. 35 also, they added the 15 megahertz. In 1936, at the request of several musical organizations, they added the 440 hertz tone, which is A above middle C. People could do their own thing. The 440 hertz is still used and still broadcast by the station today. And in 1 kilohertz, and I'm sorry, in 1937, they added the 1 second pulses that we're familiar with at 1 kilohertz, which is much more an audible frequency. And in 1939, they added a 20 megahertz broadcast. There's a staff at the Beltsville, Maryland site at the farmhouse, 18 full-time staff. Interesting point, this was more staff just for the Beltsville WWV broadcast than there was for the entire radio section at the end of the war. So WWV became one of the major portions and parts of the radio section until disaster struck. On November 6, 1940, the Beltsville house burnt down. The only thing that was saved was the crystal oscillators that were in the basement. Everything else was destroyed. But in just 5 days, they were up and running again with that old 5 megahertz, 1 kilowatt transmitter that was housed over on Shepherd's Road, I believe it was, or at, what was it? I've got it here. Oh, over on College Park, over in College Park. Now, this was an incredibly dangerous point in time. This is November 6, 1940. The European war had started that earlier September. We see war on the horizon. In fact, war would start in just 1 more year. So, go ahead. So, the Congress allocated, at the time, a whopping amount of money, $230,000, to begin construction of a new brick building about 3 miles southeast of that original farmhouse in what was still called Beltsville, but to distinguish them, they started calling it Greenbelt. I believe that name stuck because you can see this is the building that we're standing in presently today. Another one, please. You can see the antenna fields that surrounded all of this. This was in January of 1943. There you can see the transmitter room in the spring of 43, and then by the fall of 43, same transmitter room in full operation. So, at the new site, this didn't open until 43. The place burned down in 40. So all we had for WWV for that period of time was the 1 kilowatt at 5 megahertz. But that soon changed when they opened up the new building. Had the 5, 10, and 15 megahertz back in operation at 10 kilowatts, a 2.5 megahertz, 1 kilowatt, and then by 46 to 25, 30, and 35 megahertz. And I want you to pay attention to the WWV call signs that are up there. Joe, where'd Joe go? Joe showed me something a little while ago, and I didn't want to say anything to you, but that'll come up in just a moment. That'll come up and just pay attention. Joe showed me that this wall right here, that entrance, is basically right here. Most of you know it. Yeah, that's what he was showing me. Yeah, okay. So, next one, please. Here is, this is back at the Bureau, back on Connecticut Avenue. They were still doing the monitoring because they had the main crystals that was the time standard for the country. And so they would monitor all the signals from WWV and monitor this back at their own base. So did the United States Naval Observatory. Actually, so did the National Physical Laboratory in England. All of this became important when they came to the definition of what a 1 second was going to be when atomic clocks came around. They were able to monitor and measure all of these at the same time and synchronize their own time scales, and those became valuable when they did the atomic clocks. So on November 22nd, 1948, WWVH, the sister station, the Hawaiian sister station of V, began broadcasting at Kihei on the island of Maui at 5, 10, and 15 megahertz. Then in January of 1950, voice announcements were added to all B and BH broadcasts, a male voice for WWV and a female voice for WWVH, offset slightly so they never ran over it if you were picking up both signals. And this is the very, very familiar for many of us at the tone. Heard that, you heard B or VH. Now, so in the summer of 1954, the radio section, now renamed the Central Radio Propagation Laboratory, moved to their new headquarters in Boulder, Colorado, including the 4 quartz crystals that we talked about earlier that made up the primary time and frequency standard. In the field right next to this facility, they built an experimental broadcast at 60 kilohertz, station KK2XEI, broadcasting at 2 watts, just 2 watts of radiated power. This signal was received in Harvard and Cambridge at night, over 1,700 miles away. This was the precursor to WWVB. Then in 1960, an experimental broadcast, excuse me, the experimental broadcast was set up in the mountains just west of Boulder. You can see, and this was at 20 kilohertz. This was the precursor for WWVL. You can see the antenna and the radiating element hanging here. This was almost a 2-mile long string or antenna draped across here. But 20 kilohertz is a very long wavelength, as you may understand. So one of the beautiful things about these VLF and LF broadcasts is that they were much, much stabler of received signal for trying to receive time, because they basically use the ionosphere as a waveguide, right? So your signal didn't have a sky wave and a ground wave. Basically was all just a ground wave. So next, please. So they proposed a new LF and VLF station up about 60 miles north of Boulder for a new broadcast facility for the 60 kilohertz and 20 kilohertz. The proposal was this large antenna field for the 20 kilohertz and the smaller antenna field here for the 60 kilohertz. Well, there was only funding for the smaller antenna field. Now, when you say smaller, these are 400-foot towers. So those other ones were going to be 1,200-foot towers. That was going to be a massive installation. This is big enough as it is. But they proposed that they would take the north antenna field and drive the 20 kilohertz and the south antenna field and drive the 60 kilohertz. So in 1963, VB was on air, and in August, WWVL began broadcasting. And here's a shot from the top of one of the antenna towers. You can see this capacitive top hat antenna field, which basically gave the radiating element a higher height. These frequencies are so long wavelength that you had to have some kind of, you couldn't do it just off a single tower. It's a quarter wavelength of a 5 kilometer signal. That's a pretty tall tower. So they did it with this capacitive top hat. Then I have more things. If we have time, I have much more information about BB and BL I can discuss later. But in any event, when they opened up the new broadcast signals for VB and VL, they decided that they would now begin a facility for WWV on the same grounds. They were given $1 million, 1963, to build a completely new facility. The only thing that came from here, those concrete call signs. So, Joe, there's no reason to crawl up there. No reason to crawl up there. That is the only thing they took from this facility, with those concrete call signs. So by the summer of '66, the WWV transmitter building was complete. And then they had all new transmitters, please. All new transmitters. Second to read these, the types of transmitters they were using. And then they had all new antennas, half-wave center-fed vertical dipoles. And then they also had transmission lines that were all pressurized with dehydrated air. And then on December 1st, 1966, they switched the station off here, exactly 0 hour GMT, turned on the stations in Fort Collins, and started broadcasting the new WWV out of Fort Collins. Here is the first day QSL card. That the response was outstanding. A lot of ham radio operators back in the day. They had over 10,000 first day responses that were mailed on time. They didn't give it much time. Here's Mrs. Goodlick Hicks. She was sorting through that first day mail. Here is, I think this was on the very first slide. This is the QSL card that they started using soon after that for WWV. This is in the long tradition of QSL cards. Here is a QSL card from this facility. I think this was in the late 40s. I could not find the date for this QSL card, but it's somewhere in the late 40s. It was after the war, for sure. So, then on July 1st, 1971, WWVH began operating with all new equipment also at its new site at Barking Sands in the island of Kauai on the Navy's Pacific Missile Range facility, operating at 10 kilowatts on 5, 10, and 15 megahertz, and soon thereafter at 5 kilowatts on 2.5 megahertz. This was their first QSL card? Oh, not their first. This was a QSL card commemorating the 1976, this is 2 years later, 3 years later, the 1976 U.S. Bicentennial and National Geographic-sponsored voyage of a Polynesian-style vessel that sailed from Hawaii to Tahiti without modern navigation aids. I understand this is a very sought-after QSL card because I think they only had it for a few months that summer when they did this, and so a lot of people didn't know they were doing it. I think it was only advertised in National G. So after that, in July and August of 71 and 73, they began doing the WWV and VH telephone time of day. Very nice service. By 1975, they were getting more than 1 million calls a year on this service. It's fallen off significantly since the advent of GPS, of course. And then on July 1st, 1972, WWVL at 20 kilohertz was discontinued, and VB started using the north and the south towers as just alternate towers. But then in 1999, they got all new transmitters, all new helix houses, and we were able to start doing a dual array broadcast. This took this from what was a 13 kilowatt broadcast effective radiated power to 70 kilowatts of effective radiated power. Another big advancement was both at V and VH. They now have their own trifecta or three-corner hat time code generators, and probably more important than that, they all have their own atomic clock time scale. Bureaus no longer had to monitor and try to remotely guide the frequency disseminated, or the time, or any of the dissemination, because they now had their own atomic time scale. Then, WWV also had some upgrades during this period. One thing that we had was they had metal towers right there along the shore, and so the salty air was incredibly difficult to keep these towers in shape. We had to keep repainting them. We had to keep replacing all the hardware. So we dropped those towers. This is a 2.5 megahertz antenna. That was a fun day. And then hauled that away. And then we put up, fiberglass width antennas. Now these were initially ship-built tiles, mostly for the Navy, obviously, antennas, but we had them build a larger style of this, and then we erected these, and actually the staff won a bronze medal for their efforts for this. This is taking these shipbornes. We also put in a solar panel that the cost of electricity in Hawaii, as you can imagine, is very expensive. This solar panel basically paid for itself in about 7 years, but the cost of electricity. So what's next? What's new with WWV and WWVH? Well, one thing is the continuing investigation of the ionosphere. That was started over 100 years ago. Ham radio science citizens investigation. The idea that you take personal space weather stations, you can study eclipses and frequency measurements for eclipses, you can measure solar flares and geomagnetic storms. They actually are doing measurements of transmission through the ionosphere, completely through the ionosphere. And maybe one of my favorite things going on with this new measurements is sources of traveling ionospheric disturbances. So this is an exciting thing. ARRL is involved with this. University of Scranton, Space Western, number of other different entities. What I really love about this is, so ham radio operators, amateur radio clubs get together, build these things, and they take measurements, gather the data, and they send them back to these universities to be analyzed. And the exciting part about that is that young people are getting interested in ham radio again. We all know that there was a period that wasn't necessarily true. So that's probably the most exciting part of all this. Uh-oh, blank, shouldn't be blank. One back, I think, one back. That didn't come through. Anyway, so on October 1st, what this slide would show you, if you could see it, is that on the 100th anniversary, on over the weekend of October 1st, 2019, the Northern Colorado Amateur Radio Club, in line with all of those organizations, held a special event, and we did a citizen science measurement of distributed Doppler measurements. Next one. Which included over 100 operators and over 10,000 contacts who had their own space weather stations. We've discovered that the ones that had their own GPS disciplined oscillator are the ones that have really significant results, because we really need stable measurements for the universities to determine some of these events like the distributed traveling ionospheric disturbances. Next one. So you too can get involved. Build yourself your own personal space weather station and a receiver. Somehow it would be better if you had some form of a GPS discipline oscillator, but there's several different ways of doing this. In fact, there is no method that is not allowed or disallowed as long as you have stability and you can measure the WWV broadcast or VH broadcast at very defined frequencies, at all the different frequencies, catalog and collect that data, and then send it into the universities that are doing this. So real quick, last part of this, these test signals that we used on the 100th anniversary had Gaussian noise, phase coherent, waves at different frequencies and different power levels, series of up and down chirps, series of bursts, and some more added white noise. Let's see if this signal's going to play. Try it. Hit it again. On the play. No, it's not going to. Try the next one. Does it go right by this? If this signal worked, what you would see is just that. You would see the addition. This is like the 2.5 megahertz broadcast. I had taken a film of this happening. You'll get the Gaussian white noise. You'll get the sine waves, side bands at different frequency levels. You'll get the chirps and all the different parts of it. This was the test signal that they used on the October 1st anniversary. They are developing and creating new test signals, and they're getting ready to do new testing parameters and collection of data. So if you're interested as a club or as an individual, you can look it up. It's going to run. Keep going to see if it'll go past it. Nope. Keep trying. Nope, apparently not. If you could see the next signal, basically it just says hamsci.org/WWV. Look up all the information you want at hamsci.org/WWV. My talk. Any questions? We got time for questions? About it, huh? Yeah, please do. Okay. If I can answer them, I'll be happy to try.
Have you guys ever looked for the original WWV license from the Bureau of Navigation?
Not from the Navigation Bureau.
Because if it was listed in the radio service bulletin, the license would have come from the Navigation Bureau. Have you ever looked for the first license?
No. Nor has any of my predecessors. We've always, we're part of the Department of Commerce.
Yeah.
So we
And
just looked at
the Bureau of Navigation.
that's very interesting point.
So the reason I asked that is all of those Department of Commerce Bureau of Navigation records, most of them still exist. They're at the National Archives. I've delved into those.
Okay, all right. So we had a bit of an issue when we found the WWV call sign just on the Department of Commerce bulletin, because we had some notes we found showing their operations prior to that.
Well, and keep in mind, those announcements in the radio service bulletin have to be 1 to 6 months. That's after the license was active.
That's what we kind of had. I could really blow my whole staff away if I came back and told them, no, you're wrong.
If you'd ever like help, I can point you in the
I
right
will
direction.
have more opportunities.
Second question, if no one else has any others. The early telephone handset for the very first voice, and do you have any idea which whose telephone handset?
Oh, no, I would assume they were Bell. Not sure.
So it could be any of the numbers.
That would be, see, right, that's one reason why I didn't try to say who that was. I can tell who the photograph was, right? But I wasn't sure who those are just, they were headsets. They were on headsets. I just assumed they were Bell.
That was before
I
consolidation.
think you're right, before consolidation. And Grand Bell, my buddy, that building.
Well, Bell, Western Electric was still around, or was around at that point, but they had not been taken over by AT&T. They were part of the Bell system, didn't come around.
That's a good,
Were those carbon-based pickups?
they were coil.
Oh, they were cool.
They were coil. That I'm pretty sure of. They weren't, some of the early ones were vibration carbon platters, but I think those early ones were coil. Yes.
When you visit the U.S. Naval Observatory in Washington, that was an ensemble of atomic clocks, and they claim to be the nation's system. So
Yeah, I can tell you exactly the differences. We both have an ensemble of atomic clocks, including some of the obviously hydrogen majors, some of the new much, in fact, most of our time scales are now driven by optical clocks, either of aluminum or mercury or any cadmium. The United States Naval Observatory is in charge of time of day. We are in charge of frequency. Interval time. And National Institute of Standards and Technology, we're in interval time. They are time of day. The truth is, we do it both. They're one of the same. And so we cooperate. There was a time that USNO and NIST had some rivalry. No longer. Not when I was actually in the management forum. I know for a fact that we got along great because we shared all of our data, all of our information, as well as our personnel. So that's the difference.
do they provide correction?
Nobody provides, the BITM in Paris provides corrections to both of our signals. Everybody in the joint sends all of their signals to the BITM in Paris, and the BITM in Paris takes a international ensemble, and then they send out corrections from there.
What's the relationship to Greenwich, if any?
Greenwich Mean Time is no longer exists.
Okay.
Yeah, GMT was replaced with UTC, United and Universal Coordinated Time. And Universal Coordinated, I'm on the International Telecommunications Union body. I just came back from Geneva on this. We're getting ready to get rid of the lead second. Lead second is a pain in the butt. That's not official U.S. jargon. But the problem with the lead second is step in the time scale. Your time scale, and so many different organizations. For instance, Google, they smear that last second across to get an extra second in. We haven't had a lead second in 7 years. Every time we do have a lead second, there are several technological bodies that have problems. Reddit, Qantas Airlines shut down for several hours after one of the lead seconds occurred a while back. So we haven't had one for 7 years. The next one's possibly going to be an 80 lead second, which we've never had. The Earth is slowing, the Earth is speeding up. He says arguments about why the Earth is speeding up. My personal opinion, from some of the data I've seen, like a skater pulling their arms in, we're losing our glaciers. The Earth is speeding up because the distribution of mass about the geoid,
Outer rotation.
yeah, outer rotation is crazy. Hasn't happened yet. The International Earth Rotation Service is not claimed when they're aware the next lead second, if we're going to need to let the next lead second. But the negative lead second would be even more of a pain than positive. Nobody's ever had to try to deal with the negative lead second. Only positive. But I can guarantee it's been so long since we've had a problem, so much technology is not prepared for it. It's not like today. We know it's coming and program it in. The lead second is done on certain days of the year. We don't know when that's coming. And so the international body is trying to get rid of the lead second. It was a really difficult meeting this year because the Russian delegation, I can say this, the Russian delegation didn't want to do anything. Since the advent of the war, they're not cooperating with anything. So I'm not real sure. The next international body is next year. We sent our information in. We'll see what happens. Yes.
You know, they still go to the ISS with us.
The International Space Station?
Yeah.
Yeah, they do. They're up there. That's kind of hard to get out of it then.
But my question is, the NASA Goddard came here in the 60s. And we had our atomic time standard right there at the bottom of the hill with Building 12.
Mm-hmm.
You know anything about how they interrelated to you guys up here before you know, are you still operating?
This particular time scale? No, I'm not sure. You know, there was everybody had their own time scale that needed accurate time because in order to broadcast time, you can't pick up parts of 10 to the 13th at 1 second via any radio signal.
Yeah.
Can't do that. You have to have on site your own oscillator of that kind of level of accuracy, stability, that level of stability in order to propagate it throughout your own organization. But if you wanted the accuracy, then you did have to have some kind of a chain of command, a chain of link back to the National Institute of Standards. Yes.
I believe that decisions to move from the site was caused by the arrival of the Goddard Spaceflight.
Not that I'm aware of. My understanding was they built WWV and WWVL as a new facility in Fort Collins, 224-acre site. They had lots of room. Let's build B here with all brand new instances. The only thing was the science. They built it completely new. I don't think they were forced out. I don't think so. So I don't know the answer for sure. I don't think they were forced out. I think they decided to move because they had a new facility facility in a new location, and they can start from scratch.
Under coverage.
Better coverage for one, because they're more towards the central location of the country, and so that broadcast can cover more of the continental United States. You know, the Bureau itself was moved because of politics. It was given permission during the Truman administration, and during that period, the Red Scare was happening, and they wanted to take more and more of the infrastructure, the critical infrastructure, and get it out of the DC area. And so that's one of the reasons why the Bureau was moved to Boulder.
I've read that they moved it to the interference between WWV and WWVH from the West Coast out into the Pacific Ocean.
From WWVH? No, from rugby in England. No, the NPL was also broadcasting.
Well, when they moved from here to Boulder, it was to move interference between WWV and WWV. West Coast out into the
My understanding was the Bureau moved the time and frequency, the Central Propagation Laboratory out there to get it out of, they were out of Brewer, Connecticut. They wanted their own facility. This was, time and frequency was obviously extremely important for a part of the Bureau's function, its focus. And so they moved them out there to get their own. They had no more room back in DC. Interference could very well. Boulder, Colorado won that over a couple different cities. One, because they had a university close by. Two, it was a radio quiet area. So there's some truth to what you're saying. Yeah, I'll have to bring it back.
How much of this building is original?
This? I have no clue. There you go.
This is all new. All new. But right to those doors on that hallway, they're on. Got it on this side. You can have an experience. Lights are off in there and just stand in there and see if you feel the energy.
So this was the side.
I'm going home, but after the 1940 fire, did the military fill in? The two active 4 years of being with the standard business when you were down on treatment?
The only thing that I understand is they were broadcasting at 5 megahertz at 1 kilowatt from here.
But did the military fill in with other services? I mean, they had World War going on.
Not quite yet. They had another year, but 2 years prior to that, they didn't have a World War going on. I do not know the answer to that. I can only assume that the military had their own reference frequencies that they must have been broadcasting, especially to ships at sea, because they needed their own synchronized time so that they could do navigation. I mean, this wasn't.
That's what's still running.
Who was?
NSF and
Yeah, NSF probably. Well, and CHU in Canada was still operating, but I mean that wasn't ours.
So what's the current power right now?
WWV is 10 kilowatts at 5, 10, and 15 megahertz. 5 kilowatts at 2.5 and 20. And we have an experimental one in Fort Collins right now that's doing
25, right?
25, 2.5 kilowatts at 25.
Yeah.
Sure.
Yes.
I have a question about your 60 kilohertz operation. Do you have a figure for the antenna gain?
The antenna gain?
Antenna gain, yes.
Now that we went to dual antenna, they were just.
Whatever's on the air.
Yes, whatever's on the gain. You're talking about the broadcast.
I'm talking about the gain, be it a positive number or a negative number.
It's a negative number.
Yeah, it's got to be a negative.
Oh, it's way negative number. Yeah. Because 60 kilohertz is a 5 kilometer wavelength. If you wanted to have, you'd have to do a quarter wavelength.
Right. It's a positive response antenna.
It's a very low gain. But there's a whole lot more information there. We've done a number of different things to increase the gain on WWV. One is, it was a amplitude modulated signal, mostly DB is only used for clocks and watches and those kind of devices anymore. Nobody uses the WWV disciplined oscillator. And everybody does that GPS. But when we did bump the power, they started burgeoning. I mean, there's tens and tens. I think they're close to 100 million devices out there that are radio received, clocks and watches, wall clocks, all those kind of devices. Well, rugby from NPL in England broadcasts 50 kilohertz too. So all along the eastern seaboard here, we would get interference. So the first thing we did was increase modulation depth. That gave us a couple dB of gain, but it didn't solve the problem. And so the last 10 years of my management, we went in and put phase modulation on the signal, keeping the amplitude modulation backwards compatible. Picked up 18 dB of signal gain. So if you buy a chip that is capable of pulling out the phase modulation, these things work. There's a watch that a friend of mine went to Cape Town, South Africa, and it worked. It worked.
Well, this one I have a watch here, but.
That's old. That's probably going to be the amplitude modulation.
Yeah, because I'd say about 25% of the time it doesn't get.
And the reason you don't, it's not because of power, because of interference from rugby.
Oh, okay.
From England. And because they'll pick it up in Hawaii, really twice as far away, but they don't have the interference that direction. So they're coming out. This just happened not too long ago. They've just started coming out with the wall clocks. I don't think they've made this chip small enough to put it in a watch. I said that earlier. Watch. He had a wall clock that he took down to South Africa. It's been picked up in Patagonia. Wow. It travels. It's got great gain because we don't have any interference from amplitude. Amplitude modulation, you get interference from almost anything. Yeah. From the television, from that screen, will interfere with it. You get phase modulation, it gets rid of a lot of that background noise. You picked up a whole lot of gain just in that manner. We good?
Yeah, I'm just curious.
No, if you guys are willing to go, I'll stand here all night.
What time is your plane tomorrow morning?
No, my plane's not till the afternoon. Hey, that is one important thing. Am I going to get a ride back to my hotel room tonight? And what time?
I can, yeah.
So we've got some time. Yeah, we've got some more time, and I'd be happy to sit and answer more questions. I didn't even start over here.
So when you went back to when you started doing, or WWV started doing voice and music and stuff like that, do you know if they ever recorded anything?
No, as far as I know, and I've searched for that. As far as any of us know, we can't find any of the recorded. I would love to have their commercials, their soap commercials. But no, as far as I understand of that period, before they became a standard broadcast service, there doesn't seem to be any recordings of some of their efforts.
Wire, problem. No.
It would have been.
It would have been Bell.
They could have done it. They could have done it on the dome.
General Electric was doing WGY in Schenectady on motion picture film in early 1921.
Yeah, I have heard recordings from the 30s.
Yeah.
Yes.
Totally trivia type question, but so I was curious, having stumbled across it in the 80s as just a geeky kid on the radio, and I didn't get into ham radio until later. But I always wondered why did they re-record the voice?
Re-record because we went from an old cylinder wax. It wasn't really wax. It was some kind of a.
It was one of the bell system ones.
Yeah,
where they had a magnetic
and then we went to
cylinder that turned.
Then we went to digital memory of that. Jane Barbie was the voice. Jane Barbie was the voice for WWV. I can't remember the name of the male. I'm sorry, the male voice, but he was another actor from that period that did the voice for WWV, and Jane Barbie was for WWVH.
His voice voice, it just, I don't know, it had this sound that it was
Very
disappointing to hear it
distinct.
go away, yes.
Yeah, very distinctive. Both of those voices, they were actors and actors. Very distinctive voices that were memorable. Yeah, yes.
There was a proposal several years ago to shut down WWV.
Yeah. What happened is we fought like hell.
Yeah, sure.
For one, I actually got to, it wasn't in congressional, in one of the subcommittees, I was asked to justify their existence. Telling you this new ham size stuff would have been so much better if I had that then. I didn't. And so one of the things I said was, we're a one-way service. We don't know how many operators we have out there. We're a one-way service. How do we know how many people are picking this up? So I did a brief survey in the early 2000s. I hope some of you might have responded to that. We got a very good response. That was the one thing that I had that showed that I could take to these congressional people, show them this is still a popular and valuable thing. Now with new operations on studying the ionosphere, that is safe in a lot of ways. I wish I would have had that information when I was testifying, because that's just, they don't understand what we're talking about when you talk about traveling ionospheric disturbance, but it sounds that important.
Why did you get rid of the 30, the 1.5 megahertz?
Mostly because no one was using them.
Okay.
Mostly because no one was using them, and the fading was bad. You know, they were using them because you couldn't pick them up. Why look for the 30 when I know I can find the 15 or the 10 or the 5? One of those three are going to normally be around. And so some of the other frequencies just weren't being used. And we learned that, once again, it's a one-way service. We learned that by doing surveys. That's one of the reasons. We had dropped the 25 and just started it up again, only on a whim of the staff. We had the antenna. It was there. We had this old transmitter. And they go, well, and they put up a 25 broadcast, played around with it, got it nice and dialed in, kept it running, asked me if they could keep it running. Sure. Then people started responding to us. Hey, I love your new 25, blah, blah, blah. So we initially officially said, we're doing 25.
How long is 35?
How long? Yeah, it's been years since 35 was shut down.
It's an old transmitter. How old is your oldest transmitter in use?
Yeah, 1966.
So where do you get the vacuum tubes?
We built them.
Russian supply sort of come.
You know what, the vacuum tubes themselves are not the hardest part, it's the plates. They're plate generators, and those plates lose all their electroplating, and they lose their conductivity. We have to redo those.
What were the tube types?
Oh, geez, I couldn't tell you.
4CX, 2CX, something?
Yes.
Then I'm not going to jump.
Yeah. No, the technicians. If Glenn was here, he could tell you exactly what they are. And I never dug into one of the transmitters or one of the power. Folks, thank you very much.
Thank you. Thanks everyone for coming. Thanks again to our food sponsor there. We appreciate it.
Yeah.
Thank you. Going to be back together again live